All right, grade 12s, these are the examples that we're going to be doing in class. They're from your textbook, but we will reteach them, but this is just so you can get ahead with it. Please do not use your textbook's way of doing general solution. That uses the quadrant method. We teach the equation method. So you're going to use your regular rules that we've taught you from grade 11 and from our other videos. So please, when you're going through this, use this set of notes or slides, and this is something we will do in class with you as well. All right, so just remember, your aim is to get your sine, cos, or tan, so sine, cos, or tan, equal to a number, and it doesn't matter if it's sine, let's say it's sine 2 theta, as long as there's nothing multiplied or added or subtracted onto the end of it. So if it's sine 2 theta equals number, then you can work with it. All right, so let's just get rid of all this. Okay, so we're working with now example 14 from your textbook. It says solve for theta. I'm just going to run through it with you. Again, your textbook has a completely different way of doing it. You're welcome to use it if a tutor has explained it to you, but this is the much quicker, better way to work with it. So this is the question. Solve for theta if cos theta cos 24 plus sine theta sine 24 is equal to 0,715, and they've given you a interval restriction between -90 and 90. So the first thing is to recognize that this is the cos compound angle, and then we're left with cos angle equals number. So then we can go back here. Cos angle equals number is equal to positive or negative, so positive or negative cos plus K360. So in your calculator, you're going to say shift cos, and you're going to type in your 0,715. Your calculator is then going to give you the angle of 44,356 something something something. So you're going to use positive, negative, separated completely. Please use an or between them. So then you're left with the angle that was with the cos equal to the angle that your calculator has given you. And then you just got to get theta by itself. So you're going to take the 24 across, it becomes positive. So theta by itself is 68,36 plus K360. And so the second you drop the cos, that step there, you have to make sure that you bring in the general solution, the plus minus and the plus K360. Then you're working on the other side. You're going to take your -24 across. It becomes positive on the other side. And so you have -44 plus 24, and you round off to 2 decimal places, -20,36 plus K360. Please don't forget to give your K as an element of integers. All right, so then you've got to work with, if you have between only -90 to 90. So in your calculators, you'll type in 68,36. Then you try add one lot of 360 and subtract one lot of 360 from it. Both of those will give you answers that are far too big for this interval, so we only take the 68,36. Same thing with the -20,36. If you add a 360 or you subtract a 360, it takes you out of the interval of -90 to 90, so we only take just the angle plus no 360s. So that interval is giving us a restriction that we can only have 2 answers. Again, if you haven't watched the video that I've put up, it's really just talking about if we had a cos graph that has been shifted by 24 degrees, okay, negative goes to the right, then it's asking us where that graph will cross the line that is equal to 0,715. So between -90 and 90, probably here, it would cross in those 2 points. At -20,36 and at 68,36. All right, we can't look at anything else because it's out of that interval. All right, for the next one, they're saying show that if cos 30 theta plus 30 equals a half sine theta. That means that is. Okay, so when they say if that, so that means that is true, then we can get to tan theta equals root 3 over 2. So you have to work with this as a true statement. You're allowed to move things left and right. It's not a normal identity left and right hand side. They've told you that is true. You just got to rearrange it to get it down to tan theta is root 3 over 2. So the idea here is first to expand into your compound angle with cos, sine, sine. Remember to take the opposite sign for cos. And then we can substitute in our special angles. So cos 30 is root 3 over 2, sine 30 is a half. Now, in order to work with your left and right here, okay, we are multiplying everything by 2. So once you multiply everything by 2, we get rid of that denominator, that denominator, that denominator. So that's why we're left with just a root 3 cos theta, and then just a sine theta, and just a sine theta over there. Right, and now if we get all our sines to one side, so we're taking the sines across, we end up with 2 sines on that side and a root 3 cos on the left-hand side. Now, when you have sine and cos of the same angle, you can divide by cos theta. So it's actually root 3 cos theta all over cos theta is equal to 2 sine theta over cos theta. You're only allowed to do that if you have theta. Sorry about that. So you can only do it for theta and theta if you have both. And so then that the coses cancel out. The sine over cos becomes a 2 tan theta. You only have a root 3 left there. And you take the 2 over and you get root 3 over 2 is equal to tan theta. All right, so you just have to watch out for these ones where they're telling you a true statement. You're not proving it left-hand side, right-hand side. All right, so then now for B, it says, hence find the general solution for cos theta plus 30 equals a half sine theta. So the whole point of that was to use the shorter version. And so you're going to do your general solution with that, so that otherwise you're going to have to be working with a co-ratio situation over there. So we are working with tan theta equals root 3 over 2. So in your calculator, shift tan of root 3 over 2, and it gets you 40,89, 2 decimal places. For tan, just plus k 180. K is an element of integers. There's no plus minus, there's no other way. It's just angle plus k 180. All right, then moving on to example 15, it says find the general solution of sine 2 alpha plus 2 sine alpha equals 0. So in this case, we're working with our double angle here, which expands. And then the rest of these ones, in order to get your sine, cos, and tan by itself, tends to be basic algebra. So in this case, we have a highest common factor of 2 sine alpha. So we end up taking out a 2 sine alpha, and we're left with a cos alpha plus 1. And so then it's equal to 0 already, so you'd say sine alpha is equal to 0, or cos alpha is equal to negative 1, because it's cos alpha plus 1 equals 0, so you get the negative 1 when you take the positive 1 across. And so then if you divide both sides by 2 for the sine side, you get sine by itself. You'll go shift sine in your calculator of 0. Theta will be, it's actually 0 plus k 360 degrees. But because we don't need the 0 in there, we just write it as k 360 as is. All right. Or it would be 180 minus 0. 0 plus k 360, which again we don't need the 0 in there, so we take it out and we're just left with 180 plus k 360. Or on the other side, you've got to use your shift cos on your calculator of negative 1, which gets you 180, but because it's cos, we look at plus minus 180 plus k 360. All right. Okay, so for part B, it's also more algebra than anything else. This one has already been done for you. It's very much like what you got in grade 11. There's no double angles, no matric work here. All it is a trinomial example. So you recognize a trinomial when you have a squared, a single power, and a constant. So in this case, we have sine, squared, sine, and a number. So we are factorizing it. Now, some of you battle to see it. So imagine, or do it in rough on the side. Please don't do it in your question. But you can imagine this is 2x squared plus x minus 3 equal to 0. And then you would have to factorize it as 2x and an x, a 3 and a 1, a plus and a minus. All right, and then instead of x, you're going to put back your sine alpha. So if you can see it straight away, it's obviously quicker to then put in your 2 sine alpha plus 3 sine alpha minus 1. And then each bracket equals 0, so you can solve each bracket individually. And then so sine alpha equals negative 3 over 2, or sine alpha equals 1. Just going to talk about the sine alpha equals 1. Sine angle equals number. You can say shift sine on your calculator, and it's going to give you 90 plus K360. Now, you're supposed to do also 180 minus the angle plus K360. But grade 12, that gives you the same answer. 180 minus 90 is still 90 degrees. So you don't have to show both sets if it's going to get you the same answer. Now let's talk about why this answer gets you a no solution. We need to go back to our function section. So a sine graph, basic sine graph, because that's what that is, sine alpha, okay, has a period of 1. So it goes, its range is negative 1 to 1. This is asking us negative 1.5. There is no graph at negative 1.5. There's nothing there. So there isn't an answer in this case, so we say no solution. Right, going on to number C now. This one has the cos double angle, which causes some problems in your life because there are 3 options of what you can change it to. So you could change it to the cos squared alpha minus sine squared alpha, or the 2 cos squared alpha minus 1, or the 1 minus 2 sine squared alpha. So you've got to see what best fits here. So in this case, we have a cos 2 alpha and a cos alpha. I don't want to now mix in a sine. So I'm not going to bring in this one. I'm not going to bring in this one. So it forces me to use just coses. So cos squared, the 2 cos squared minus 1, and then plus cos alpha. So then it forms a trinomial with coses. Again, you can use little x's on the side if you need, but you're factorizing this into a trinomial here. So you are more than welcome to make it 2x minus 1, x plus 1, but in rough, on the side, we don't want to see it at all. Okay, we do not need to see it. You would actually lose marks if you put it in. All right, so then your first bracket equals 0, so cos alpha equals 1, and your second means cos alpha equals negative 1. So remember, for cos, it's plus minus. Shift cos of a half is 60, so it's plus minus 60. And then cos of negative 1 is plus minus 180, plus K360. And don't forget your element of integers. All right, 2 more examples. Example 16 says solve for alpha again. 1 plus sine 2 alpha minus 4 sine squared alpha equals 0. And they're given a restriction that you must work between negative 180 and 90. This is only for the end of the question. You always do the general solution first, even with these specific answers, and then you go to the final interval. All right, so you're still trying to get sine, cos, tan equal to a number so that you can work out your general solution. So we're starting here with 1 plus sine 2 alpha, that's a double angle. You only have one choice on what you can change it to. So here you are forced to bring a cos in, even though we seem to be working with sines. Now, in order to get a mixed middle term with a sine squared, you must bring in a cos squared. All right, so there is a note that I have put up on the Google Classroom, a general solution summary. It gives you all these options on how to factorize the different types of trinomials. So this ends up being a trinomial with a cos squared, a sine squared, and then a mixed middle term. All right, it's like having x squared plus 2xy plus a y squared at the end. All right, so in this case, we are going to just group our sine squareds together. So sine squared minus 4 sine squared is negative 3 sine squared alpha. Our middle term has to stay the same, and our cos squared is by itself. Then this trinomial factorizes into this. And if you're not sure if you've done it right, just do a quick FOIL in your head or in rough on the side and see that you could go back to the previous trinomial step. So in this case, we get cos squared minus sine squared, cos alpha minus sine alpha, and cos alpha plus 3 sine alpha. So the first bracket, if you make it equal to 0, you take the cos across, cos alpha equals sine alpha, and if you divide by cos here, so divide by cos alpha, divide by cos alpha. Again, you can only do this when you have the same angle for sine and cos. So cos divided by cos is the 1, and sine divided by cos is the tan. Then cos alpha on the other side, take the sine over, it will be negative 3 sine alpha. So then again, divide by cos alpha. Okay, that becomes the 3 tan alpha, and then equals to 1, but then it should actually be negative here and positive, but then we can divide both sides by negative to get that. All right, and then we take the 3 across and we get tan alpha equals negative 1/3. All right, so again, a lot of algebra happening. Okay, so once we're now down to tan angle equals number, tan angle equals number, you can click Shift Tan on your calculator of 1, it gives you 45 plus K180, and Shift Tan of negative 1/3 gives you negative 18,43 to 2 decimal places plus K180. Then we've got to work on the idea of the specific answers. So we've done our general solution, and now we have to figure out which answers would fit into that interval from there. So in my calculator, I would type in 45. Then I'd say, does 45 lie between negative 180 and 90? Yes, it does. Then I type in 45 plus 360, for tan it's 180. Is that going to get me an answer between negative 180 and 90? No, it's not. It's going to be too big. Then I'd say 45 minus 180. Okay, we'll see that answer. And then we get negative 18,43 on its own, so plus no 180s. And then plus one lot of 180, and then minus one lot of 180. Okay, so this will get you 135, which does fit in, negative 135, which does fit in the negative 180 to 90 scenario. Then if we look, negative 18,43 plus no lots of 180 means negative 18,43 fits. Then if I add 180 to this, we're going to get bigger than 90 degrees. And in this case, we get, let's see, negative 18.43 minus 180 gets us negative 198,43. That won't work. So that's why we're only picking the 3 answers in the specific interval here. All right, for the last example, it is the co-ratio type. So now this happens when you have 2 different angles, cos of 3x, sine of x. You can't make it a tan. Okay, you could only make it a tan if it was cos 3x, sine 3x, or cos x, sine x. So we have to work with a co-ratio. Now, I prefer to, like in this example here, change the right-hand side. So I'm changing a sine to a cos 90 minus, because remember, they are co-ratios. So they have a relationship between 90 degrees. So if you added up these two, x and 90 minus x, you get an answer of 90. So then now you have cos angle equals cos angle. So you can then drop the common cos. But remember, once you drop a cos, sine, or tan, you have to use your general solution. So I drop the cos, and I get 3x equals to positive bracket plus k360, or 3x equal to negative bracket plus k360. All right, so let's get rid of that. So then we're working with 3x equal to the positive, 3x equal to the negative. So for the first one, you need to open up the bracket and bring the x across. It becomes 4x, and 90 is all alone, plus k360. Divide by 4, so it becomes x. 90 divided by 4 is 22.5, and 360 divided by 4 is 90. You don't divide the k by 4. The k is attached to the 360, so the 360 gets it. Then on the other side, you need to distribute this negative in. Please don't forget. So it becomes negative 90 plus x plus k360. Take your x across. It becomes 2x is equal to negative 90. And so dividing everything by 2, you get x is equal to negative 45 plus k180. Please make sure that somewhere along the line you have mentioned that k is an element of integers. Okay, for the last one, another co-ratio type, I'm going to do it as Miss McGrath has written it out from her slides, and then I'm going to do it just changing the right-hand side. So in this case, we have a bit of a problem here because we have this negative here. And the reason I know it's a co-ratio is because it's sine angle cos of a different angle. So there's another step sort of in between here. So if you want to see, if we divide both sides by negative, it's negative sine theta, 3 theta plus 30 equals then cos 2 theta. So I've just moved the sine, the cos's negative across to the sine. But now we know that sine of a negative angle is equal to negative sine of that angle. So if you're given negative sine of an angle, you can then take it back in to that angle. So that's what's happened here. So we're taking that negative back in. So it's not algebra, it's using the reverse of the negative angle rule for sine. So that's where this negative has happened inside the bracket. So now in this case, Ms. McGrath has used cos on both sides. So she has changed the sine on the left-hand side rather, to match the cos on the right-hand side. So sine of an angle is the same as cos 90 minus that angle. And then you sort out your bracket by distributing your negative in. And then you're left with cos of an angle equals cos of an angle. Because they're both cos and cos, you can drop the coses. But as soon as you drop cos, you start with your general solution. So we know it's going to be positive. So bracket equals positive 2 theta, bracket equals negative 2 theta plus k360. And then you're just taking your numbers across, okay, and bringing your thetas across. So 3 theta minus 2 theta gets you the theta. The 120 goes across and becomes negative. On the other side, we end up taking the negative 2 theta across, and it becomes 5 theta, and taking the 120 across, it becomes negative 120. Then we divide by 5, and we get negative 24 plus k72. It was a general solution, no given interval, so those are your final answers. So you leave your answers as those. All right, so if we're working with from that same sort of step, if we went sine negative 3 theta minus 30, okay, so from that step equals to cos 2 theta. You'd end up, if I change the other side, so it's a theta, sine 90 minus 2 theta. So then I would drop the signs and I would apply my general solution. So it's always left-hand side bracket equals to right-hand side bracket, and you apply your general solution, plus k 360 degrees. But for sine, remember, we have or. Now, negative 3 theta minus 30 equals to 180 minus our angle in our bracket, plus k 360. All right, so then here we'd end up with negative 3 theta, and then we'd take it across, we'd add, we'd get negative theta is equal to 120 plus k 360. So theta would be negative 120. You leave it as plus k 360. And that's the same answer from above. Or on the other side, we're going to distribute our negative in. It's going to be 180 minus 90 is 90 plus 2 theta plus k 360, and negative 3 theta minus 30. I'm going to bring that across, make it 120, bring that across, negative 5 theta plus k 360, and so it's still going to get you negative 24 plus k 72. We always leave the plus k 360 or plus k 72 as positive because k is an integer, so you can substitute a negative or positive into it, so it doesn't really matter. So you leave it always as positive. All right, so from this point onwards now, you can work on the exercises from the textbook. Again, just remember, please don't check your answers from the back. They are not going to be the same method. They use the quadrant method. This is the equation method. So just wait until we get back to school and we mark these exercises. Exercise 9 is grade 11 based, so there's actually not much that's changed. You should be able to do that. But exercise 10 is now using the double angles and the compound angles within general solution. Again, once you get down to sine angle equals number, or cos angle equals number, or tan angle equals number, it's always the same. Either theta equals angle plus k 360 or 180 minus the angle plus k 360, or for cos we're working with plus minus the angle plus k 360, or for tan it's the angle plus k 180. It's just getting to that point. It's working through all the sort of matrix stuff and all the algebra. That's where it gets tricky. So you need to practice that. The general solution should be set in place from last year. All right, grade 12s, that is it for general solution, and I will be posting up a video on the trig triangles soon.